Good morning, everybody. We'll give it a couple more minutes for folks to sign on, and then we'll go ahead and get started. Thank you again for being flexible. Okie dokie, we might just have a small class today, in which case we'll just go ahead and get started.
Professor Myers.
Yeah.
So for my take home, I have to still give it to you. But I thought we was gonna have class in person today. So
Sure.
Should I just email it to you or?
That's perfect. Yeah, and if anyone else doesn't turn in your take home, just email it to me. Yeah, that's great, Jalen.
Okay, I'll do the same.
Okay.
Yep, that's perfect. And I am just gonna pull up the participant list so I can give you all credit for being here. You may hear my daughter in the background. So hopefully you will find that endearing. Just checking everybody off here, just so I can kind of keep track of how everyone's doing as per usual, making sure nobody is slipping through the cracks or, in the scenario I'm in and not getting support. So hopefully other folks will not be struggling in the same way. We are going to get COVID tests today to see what's going on. So, fun. Alrighty, so I haven't had a chance to grade your exams yet because pretty much right after your class on Monday is when I found out I had to go pick my daughter up within an hour. So it's been a little hectic, but I hope to get those done this weekend at the very latest, so that you all will have feedback on them. Yeah, and if you email it to me, I can just print it out and staple it to your in-class. If you haven't taken the in-class, I know a couple of you had to miss, let me know when you set up your appointment with the Learning Center, and what I can do is just email them a copy and they can print it there. So, alrighty, so today we are going to start diving into the statsy part of the class, and I'm going to give you lots of practice in class on assignments, things along those lines. And I'm going to try something that I did last year, and hopefully I can make it work. So last year I did a lot of this, where I actually stood to lecture as if I was in class. And I feel like it just gives a fun vibe. Oh, real quick before I put this up, I should show you, I wore my statsy dress today for y'all. So all my tables and figures to go with your chapter. So if you have your copy of testing and essentials of testing and assessment, it might help to have this open next to you, because I'm going to be referencing it quite a bit. If you've printed out the slides, just know that they are optimized for the previous version of this book. For whatever reason, the last time I taught this, I didn't update it. So I went ahead and updated it on the slides that I'll be showing. So that'll keep you along those lines. If you do have the second edition of the book, just know they're all the same table and figure numbers. It's just they're 4.1 instead of 6.1. So let me go ahead and get the chat up. Please feel free to either unmute yourselves if you have questions, or to go ahead and just put a question in the comments as you have them as they arise. I am going to try to go through this pretty slowly, so it's, you know, again, I know some people just get like really overwhelmed with the idea of doing stats, but it is really important to understand the basics behind assessment of why we do what we do, not only when we're doing research about these things, but also when we are doing actual one-on-one assessment with a person. Like, why do we take the time to score it? And why are we comparing it to norms? And why is that so important? Right? So that's definitely something. Sorry, I'm laughing because I don't know if you all will be able to see this, but I have had to change the chapter number on this lecture 3 times because they just keep sort of moving chapters around in your book. So I just glanced on and saw that. But it's all the same information, just in a slightly different place. So, and if you've taken any kind of stats class before in high school or here at Wesleyan, some of this will come back to you. Even if you haven't taken a stats class, some of this may seem familiar from, you know, maybe even your science classes. You may have covered some of this. So, but again, I'm going to try and go through it slowly so that we can all be on the same page. All righty. So let's start with this question. And again, feel free to type stuff in the chat or unmute yourself or even use the raise hand feature. Why do you think we need statistics? Why are we even bothering talking about math in psychology? Again, feel free to just like throw stuff in the chat.
I think it's important to keep track of everything we're doing and like the research we find.
Yeah, I think that's a really, really good point. Yeah. It's going to allow us to, you know, we could do research and really good research on a lot of different people, right? But if we don't have any way to make that data make sense, it's not that helpful. Even something like, so for example, I'm working on a qualitative study right now, which is where you ask people to like write or say something about something, and then you actually code that. So a lot of people think, oh, well, you're doing that, so like you don't need any stats for that. Actually, we are going to compare it to surveys they also filled out and see if, you know, their scores on a certain survey are related to how they responded to these, for example. Yeah, so the test data collected during research and we see results, being able to interpret research and being able to share our results. And then for assessment, and again, this is new to you all, so no worries that you didn't think of this immediately. But for assessment, what we do tend to see is that we use these statistics in that individual setting, right? So we might not be doing this like while the client's in the room with us, but in order to write up a report, we're going to have to do some transformations of the scores we get while we're in the room with the patient or client. Oh, I should do a quick sidebar on that. So depending on the setting you would be seeing people in, the people you're interacting with may be called different things. So I was taught that we should refer to the folks we interact with as psychologists as clients. It's a little more empowering than patient. Patient implies like the doctor's going to come and tell you what to do. If you are a client, it's like you're a client of an attorney, right? You're going to work with your attorney to make that happen. Some people prefer the term consumer. They find that more empowering. And so there is some move within consumer-centered psychology to use that term. Just me personally, I don't like that one as much, just because it feels like you're going to target instead of like doing something very intellectual, right? And then again, depending on the setting you're doing assessments, you might refer to these folks as students, right? Because that's what they are, or, you know, whatever defendants, or, you know, that you would use in terms of legal terminology. So what this allows us to do, what statistics allow us to do on a really applied setting, is to take these raw scores we're going to get from interacting with our clients and turn them into something that's meaningful and that can give us an interpretation that may diagnose them or show us how they're doing on something, and then help us come up with a plan to, come up with accommodations, come up with therapy treatment, that type of thing. So your book outlines two major purposes. The first is descriptions, and that's really what we're going to cover in this chapter. And that is essentially summaries of data and evaluating scores relative to other things, maybe other people who've taken the test or things along those lines. And then inferences. So inferences we'll cover in another chapter, but these are essentially where you run statistics, where you compare variables. They allow us to make logical deductions about events that we cannot observe directly. So I'll say that again. Inferences allow us to make logical deductions about events that cannot be observed directly. So for example, we may be able to get someone's score on depression and their score on stress, going back to one of the examples we used when we were talking about correlation, right? But that doesn't necessarily mean we know exactly how their stress is leading to their depression unless we sort of follow them around, right? So statistics can allow us to actually look at that. Have to remember, I can use this thing. You don't have to bend over. All right. Easy. There we go. All right, so let's talk about raw scores. So Jeremiah might score a 47 on an exam, and Elise scored a 95 on an exam for a different class. Who did better?
I guess it would really just kind of depend on what they're assessing and why.
Right. Yeah, exactly. Right. And so what is this a test about? How are they assessing it? Some of the things on the screen here is how many items are there on the test, right? So if Jeremiah's test he took had 47 items and he scored a 47, awesome. If Elise's test had 100 items, great. But if it had 950 items and she only scored a 95, not so good, right? We also might want to look at the average score of how everyone took the test. So I think I might have mentioned this previously that, when I was in college and I took organic chemistry, our professor just made the average of the test a B. And the average was usually like a 27 out of 50, right? So again, depending on the class, that might have different meaning. And the other thing we need to know is, is a higher score better or is a lower score better, right? Is this something like basketball or is this something like golf, right? And so those are all things we need to know. And these are all things that descriptive statistics can start to help us with. So an important point here is that raw scores in and of themselves, without any context, are meaningless, right? We've got a number, great. And a raw score would be, a score, let's say you took a subtest of the WACE, you might get a 13 on that subtest. Like, what does that mean? We don't know, right? So they tell us very little, if anything at all, to be perfectly honest, about how an individual did on a test if we just look at them at face value, right? Because let's say that subscore in the WACE, like a 13's out of 100, not great. But in fact, at least the way the WACE used to be scored, a 13 was a pretty high score on a subscale. So, again, you need that context. Just looking at the number 13 doesn't really mean anything. In addition to test security, this is one of the main reasons we typically don't release raw scores to clients, is because they just don't make sense, right? Until you convert them and do some work with them. So you have to take those raw scores and do something to actually make meaning out of them. So things that we can do at the descriptive level that start to help us make the raw scores actually meaningful, help us actually understand what these mean. Norm group comparisons can be very helpful. So you can say, relative to how the average person scores on this test, how did that person do? Again, a 27 out of 50 on one of my psych exams would have been like, you're not doing so great, right? A 27 out of 50 on that orgo exam was average. We were doing pretty well, right? So again, that gives you context, right? Think about something like class ranking, right? Does that make a difference? So most places, for example, most high schools will just tell colleges on the paperwork they have to fill out for applications, this person ranks, third in their class. My high school was weird for a whole bunch of reasons. One was we didn't use a 4.0 GPA system. They decided it was out of 12. I don't know why. They just had to be weird. And the second thing is, this was back in the day when you mailed paper applications to people. They would actually, on the part where it says, what's their class ranking? They would say, see attached figure. And they would staple to the back of it this scatter plot of all of us. And there would be an arrow pointing to where our relative ranking was. And the reason they did that is because we were so closely clustered together in a lot of cases, because we were a very competitive college prep school, that essentially if they said, oh, well, this person is, 11th in their class, that might still mean they had an 11 point something out of 12 GPA, right? So yeah, that can be really helpful. Where is their relative position to other folks? They tell us that relative position, again, in the norm group, typically, whatever the norm group is. So for some instances, the norm group might be, everyone within that high school. For something like the SAT, it's everyone who took it nationwide, right? For something like the intelligence tests, it could be people of the same age nationwide who took it, or even they start to differentiate more as well by gender. So, you have this relative position to whichever group is decided is the norm. They also allow us to compare the results of two people who took the same test, right? And so perhaps we're really interested in, this person took an SAT prep course, right? How did they do relative to someone who didn't have the resources to do that? Spoiler alert, they do better, right? So you can kind of buy your way into better SAT scores with these prep classes. So they allow us to compare the results of test takers who took that same test. They also allow us to compare the test results on two or more different tests taken by the same individual. So thinking about class, right? If you struggle on exam 1, you come to see me for help, I can then look on exam 2 and be like, oh yeah, they did better. That's great. I was helpful, right? Or if you start going to tutoring. Also, there are tests that are purposely made for you to be able to compare the results. I'll give you an example. So I talk about the WACE and the intelligence test quite a bit. The Wechsler group who makes the WACE also makes something called the Wyatt, which is the Wechsler Individual Achievement Test. You don't need to know that right now. But basically the Wyatt is a test of how well you're doing at basic school skills, whereas the WACE is a test of what's your general intelligence. And so these two tests are actually constructed so that you can compare someone's results directly. And it essentially tells you if this person's really smart, but their achievement score is low, right? This person is not performing up to their ability. And so then that tells us we really do need to look at something like maybe a learning disability or an intentional problem, things along those lines. So that can be really important as well. Alrighty, so again, this is where you can start to follow along if you do have your copy of testing and assessment, whether again you have the physical copy or the ebook. So a frequency distribution helps us to make sense out of a set of scores. So it basically displays scores on a variable as measured, or a measure, sorry. Displays scores on a variable or measure to reflect how frequently each score was obtained. So I'll say that again. A frequency distribution, it displays all the scores on a variable or measure, so a test perhaps, to reflect how frequently each sort of, sometimes we do it by raw score, sometimes we do it by, you know, grouping, things along those lines, how frequently each score was obtained. So basically what frequency distributions allow us to do is to find all possible scores. So let's say on one of my exams, in theory, all possible scores, right, are 0 to 100. I always hope no one gets a 0, because that typically just means they didn't turn it in or take it, right? If they get 100, great, right, fabulous. And so you want to define all the possible scores and then determine how many people obtained each of these scores on that exam or that test or that assessment. So again, if you look at the distribution on page 112, table 6.1, again, I'm just going to try to hold it up for those of you who don't have it. It's just a list of numbers. And it says how many times someone got that score. So in this case, we don't know the scoring on it. But you know, there was one person who got a 66, one person who got the lowest score of 32. But then in the middle, we had like 5 who got a 50, 5 who got a 51. And that's typically what we see. Things tend to sort of follow a normal curve, which we'll cover in the next couple of minutes. I'm going to wait to do my next activity, because typically I collect data from you all and write it on the board. So hopefully I'll be able to be in Friday and do that. If not, I'll figure out a way to approximate it virtually. But we'll skip ahead and we can do that example later. All right, so once we have that table of just numbers, right, that can be somewhat helpful, but as you could see, for those of you who have your books, that's a pretty long table, right? That's really only telling us how many people scored on each thing. I don't know how helpful it is to look at it. It's not that pretty, right? So we might instead use a graph to make sense out of our frequency distribution. And there are 2 types of graphs that we often make. There's histograms or a bar graph. So you would do this either by individual score, or let's say you could clump them together. So let's think of the example of your test you took Monday, right? So if I wanted to do a histogram of your scores, I could have a bar for each score that y'all scored. In theory, I could actually have a bar from every point from 0 to 100. That'd be a pretty wide table or chart, so I probably wouldn't do that, right? Or what I could do is collapse it down to, you know, everyone who scored under 60, everyone who scored between 60 and 70, everyone who scored between 70 and 80, right? And on up from there. And that's typically what you see when you look at these bar graphs, these histograms, is that they're going to kind of break it down that way. And then frequency polygons are essentially doing the same thing in a slightly different way, and I'll show you what that looks like as we get into it. So one of the things, what I just talked about of collapsing the scores instead of graphing each individual score, collapsing them into, let's say, everyone who got an F, everyone who got a D, everyone who got a C, B, A, right? Those are called class intervals. And that will make your figure, your either histogram, the bar graph, or the frequency polygon clearer and cleaner for yourself, honestly, but then also for your intended audience, right? Whether that's, you know, me when you're turning in homework, or whether that would be you're presenting research at a conference, right? And it's, you know, whoever comes to your presentation. Or you're writing something up for a journal or even a newspaper article, right? And your community, your audience is whoever's going to read it. So class intervals basically tell you how many people scored within a grouping of scores. So class intervals are how many people scored within a grouping of scores. So again, grade on an exam or on an intelligence test, we might sort of break it into standard deviations of like average intelligence, high average intelligence, things along those lines. I think there's a category that's like superior intelligence. We name things weirdly sometimes. Just putting that out there. Alrighty. So making class intervals, and again, I typically write this on the board for y'all. But if you want to see what this looks like, we are going back to that first table in chapter 6, page 112. And basically, we would then go ahead and, you know, again, we could make a bar graph that had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So somewhere around 20 bars, right? That's not going to be fun to look at. So instead, we can just create these class intervals. So we would subtract the lowest number in our series of scores from our table from the highest number. So our highest score is 66. One person scored a 66, and our lowest score is 32. When you subtract 32 from 66, that gives you 34. And then let's say, you know, we want to do 7 class intervals. I don't remember why I chose this one. I just did when I made this example a while ago. So then what you do is you would take your, essentially your range between 66 and 32, which is 34, and divide it by the number of class intervals you want. So again, let's arbitrarily say it's 7. And so when you divide 34 by 7, it says, that's 4.86. So you want 4.86 scores per interval. Okay, we can't do a decimal of scores, so we round it up and it becomes 5, right? So then we should have these intervals of 5 points, essentially, that become our class intervals. And so here you can actually see what those class intervals are. So 32 to 36, then 37 to 41, and so on. And each of those is about 5 points. And then what we would do, instead of, again, graphing the 20 different points, 20 different scores, we would instead graph these class intervals, and those would give us a prettier, easier to understand chart. Again, oftentimes class intervals are much easier to understand because they're based on something that does make sense, right? Grades, things like that. So if you look at table 6.2 in your book, again, and I'll show you all there. Whee! it shows you how that breaks down once you collapse it, right? So now we have, you know, 2 people in that top interval of 62 to 66, 2 people in that bottom interval of 32 to 36. And not surprisingly, as I mentioned, most of the scores are clumping towards the middle. And then if you look on page 114, then you see what a histogram would look like and a frequency polygon. And so just to kind of break this down for you, the only difference between a histogram and a frequency polygon is how you connect the dots, basically, okay? So a histogram, you're gonna essentially make a dot for, you know, again, this 32 to 36 class interval. We know we have 2 people in there. So you would have like a dot for that, right? Again, the 47 to 51 class interval, I think we had 27 people there, right? So you'd make a dot for that. If you were doing a histogram, you would then draw a bar up to that, essentially a rectangle up to that dot, right? If you were making a frequency polygon, you would just connect the dots, basically. Just doop, 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 doop. Okay. So that's really the only difference between these two, is that you're making a bar graph in the histogram, and for the frequency polygon, you're just playing connect the dots. Only difference. So these are 2 ways to portray things. I would say, at least in the literature I look at, the histogram is much more commonly used. There are reasons statistically, as you get into more advanced things, you might want to use the frequency polygon. But in journal articles that I look at, we tend to see histograms. They're just, I think, easier for us to kind of conceptualize, even if you think about how like newspapers present poll results or TV, right? They often are making this sort of histogram bar graph type thing. So one of the things that becomes part of it is whether this is worth it or not, right? Like, so some people say, we just did a lot of work, right, to collect some stuff down. Is it worth it? Is it not? I think sometimes it just makes more sense to do this, right, than it does to report every single value. But other times this may be sort of an exercise in futility and you're not actually telling your audience that much information. Alrighty, so go ahead and on your piece of paper, go ahead and make yourself a frequency distribution with these numbers. And I'm going to go ahead and just try to like open a Word doc next to this and do one myself, or maybe I'll try to do it on the same slide here, just so I can demonstrate it. So go into editing. So what we're going to do is say, okay, so looks like the lowest score we have here is 15, right? And I'm counting 1, 2, 3 people with a score of 15. So there we go. So if I was to make columns, this would be score, right? And then I'll tab this over a little. This would be frequency. Yeah. All right, so then it looks like our next value is 16. Again, these raw scores don't really make that much sense to us because we don't know what they're from, right? It looks like we've got one person who scored 16. 17. Looks like, again, only 1. The beautiful thing is once you get used to doing this, there are statistics programs that will just do this stuff for you, which is lovely. All right, we do have an 18, at least 1. Looks like maybe just 1. Cool. But when we get to 19, there are 2. All right. My font is going to start getting smaller, just heads up. There is someone who scored a 20. Okay. Oh, actually, 2 people scored a 20. I missed one. So this is where this is like, were I to be doing this on the board or on a piece of paper, I would actually like cross these out as I go to make sure I'm getting everybody. Okay, so then I'm not seeing any 21s or 22s or 23s. Looks like our next score is a 24. It looks like we've got one person who scored that, right? And then it looks like we have 2 people who scored a 25. And then looks like one person who scored a 26. Right. I'm not seeing a 27, but there is somebody who scored a 28. Right. And then no 29, no 30. Oh, there's a 30. Okay, so we got 130 as well. And then we've got one person who scored 31. Looks like one who scored 32. One who scored 33. And this can happen, right? You can get data like this where it's like, oh God, come on, can someone have scored the same number? No 35s, right? No 36s, 37, 38s. We're all good until we get up to this person who scored a 42. They're the curve breaker. So this is the person usually people in class hate, right? How could you? Alrighty, let me scoot the 3 over so it's in line. Okay, so again, this is probably fairly tiny, but it gives you at least somewhat of a vibe of how you would do this. Now, one thing I will say is this is how I would make a frequency distribution. You will sometimes see people who do this and put in every number. So like they would have 21, 22, 23, always 0. Yeah, that's just a lot of extra you don't necessarily need to do, right? So that's a piece of this as well. So we just made a frequency distribution. Go us, right? But as we can see, this is super messy. This is problematic, right? None of us want to do this. So instead, what we could do is we could make a distribution that had class intervals of 5, right? And so I'm going to just go back to this same chart just because it's going to make everything easier if it's next to us as a reference. So if we're doing class intervals, right, then let's say we broke this down by 5, so we would go 15 to 19, and then we'd go 20 to 24, okay, 25 to 29. I'm second guessing myself. I know how to count to 5. 30 to 34. Okay. And we could do 35 to 39. And then we have 40 to 44. Okay. So then what we do is we just add up the people who have everything in this class interval. So we've got 3 plus 1 plus 1 plus 1 is 6, plus another 2 is 8, right? So we've got 8 people who fall into the first one. All right, and then we've got 2 plus 1, so only 3 in the 20 to 24. All right, 25 to 29, we've got 4. 30 to 34, we've got 1, 2, 3, 4, 5, easy. We don't actually have anybody in this 35 to 39, and then we just have our one person in the 40 to 44. So we just made class intervals for this. Go us. All right. All right. And so then what we could do, and I'm not going to be able to do this easily on the slides, but what y'all can do would be then to take this and make a frequency polygon and a histogram, right? So basically you would just have a y-axis that would have the frequency up to, maybe 10, since 8 is our highest. And then on your x-axis, you would have your class intervals, 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, right? And then it would be, okay, we got 8 here, and then our bar for 3 would be smaller, right? 4, then 5 would go up. And then, we wouldn't have any. There'd be a 0, and then we'd have a 1. Okay, and that would be a histogram. And then again, remember the frequency polygon, you would just make those dots and connect them. Ooh, this is a lot harder when I don't have the board, y'all. So thanks for bearing with me. So yeah, that's what we could do. Again, it makes it a lot easier than if we're using really complex data where there's a whole bunch of things that only have 1 on them. And again, imagine these are just 20 scores, right? Imagine if you had 1,000 scores, which can happen sometimes in research, right? You certainly wouldn't want to try to individually plot this, right? So instead, you collect them into these categories, the class intervals. Let me throw the captions back on for y'all here. So again, class intervals making these charts a lot easier. You will also sometimes see something called a cumulative distribution, which is also called an ogive curve. And this gives us information about the percentile rank. So like essentially the number of people who get each percentile, and where if we have one individual score, they score based on everyone else, essentially. So what you would do is you would convert the frequency of each class interval into a percentage, and then add it to the previous cumulative percent. So again, table 6.3 does this very nicely for you. F here stands for frequency. And you can see that, they sort of start with things normal, and then they add up as they go. So the cumulative percentage here is, okay, they converted to percentages first, sorry. I'm just like hiccup in my brain there. So, of these 20 answers, 3% of the people scored there, right? So then the cumulative percentage, you would say, okay, so 3 people scored the lowest percentage. But that means if we set the bar at 37, 11% of the people scored below that, right? And so by the time you get to your highest score, 100% of people have scored that way. And again, there's a nice kind of a frequency polygon, right? But essentially I connect the dots of what that looks like, right? So by the time we get to our highest scores, we know how many people are there. So this helps determine the percentage points in the distribution. And it's called, again, a percentile rank. These, I think, are most frequently used in things like achievement tests, right? So again, if you ever did SOLs growing up, things along those lines, they often tell you things like this, you are at this percentile, right? And that's what this allows you to get at, essentially. So this is called percentile rank. And essentially it asks what percent of scores fall below a certain score. And I'm just realizing we only have 5 minutes left and I want to be able to go through this slowly. So we will actually stop there for today. We'll pick up with percentile ranks on Friday. So again, assume that we will meet via Zoom unless you hear differently from me. If we're all negative, then I can come back to campus and everything will be great. So again, thank you all for your flexibility and for your understanding. And yeah, I'll stick around for a minute in case anyone has any questions about anything. And again, exams will probably get forward over the weekend.